systems of equations and inequalities. Linear systems, nonlinear systems, inequalities. What are they? When were they first invented? Well, it turns out for the system of linear equations, matrices to use to solve these, perfect. When were they invented? Actually, in the latter part of the century, like the end of the 1800s. Two mathematicians, and you see them here. On the left, James Sylvester, mathematician, started the American Journal of Mathematics. On the right, Arthur Cayley, mathematician, lawyer, mountain climber. Two very different people lived at the same time and simultaneously invented matrices. And what they did was they thought to themselves, I can go ahead and solve a system of linear equations because really all I need to do is worry about the coefficients. I can remove the variables. So you have the system that is rewritten as a series of rows and columns like that. And with just using numbers, you can go ahead and solve the systems. Now they presented it to the world in 1900 and the world said, that's really amazing. What are you going to do with it? They didn't really have a good answer. And it wasn't until 1926 when Heisenberg started working on quantum mechanics and he was writing papers and he was dealing with probability, and probability has many variables and he was using linear systems. So he switched over to matrices to save time so he didn't have to write the variables all the time. In doing that, he was able to publish the material in Germany, mind you, right before Adolf Hitler takes power. Had he not had matrices, he would have waited to publish, and because Hitler closed down all of the scientific research done by the Germans once he became in power, the world would never have seen quantum mechanics. In a sense, matrices changed our world. Now, what is matrices used for? Well, again, to solve linear equations. Imagine three linear equations that represent planes. What do the solutions represent? Well, they can represent that singular point where planes meet, because the solution are the points those three planes have in common. All three planes, mind you. But you can have another possibility. These three planes can meet along a line. In that case, you have an infinite number of solutions, which are all the points along that particular line. They can even all represent the same plane. And then you can have three planes that do not intersect at any point at all. Maybe two planes intersect along a line, but not all three. And this could come in various ways. Now, we also have something called nonlinear systems. And those could be the paths of, say, a hyperbola or parabola. This is Halley's Comet. And you know what? It circles the Earth about once every 75 years. Its path is that of an ellipse, a nonlinear path. Comets have this nonlinear path. You may want to take their paths and know when they'll meet. So you solve a system of nonlinear equations. Why would you want to know when they meet? Well, when they meet happens to occur at the same time, those two paths, then what happens? And I guess Earth would kind of want to know that. Welcome to the world of linear systems, nonlinear systems, and inequalities.